Okay, so this, by the way, this is referred to as column form for writing your solution. So you can write your solution in point form. That's what we did in section 1.1. This is called column form. So I'm just going to jot that down. There's actually another form you can use as well called row form, which we'll use that on the next example, just so we can see all the forms. So this refers to the form in which this solution has been expressed, since it has been expressed in columns. That's why it's called column form. Okay, so let's do another example. Let's do an example where we start from the very beginning and we start with exactly this type of situation you would typically see. So let's start with a linear system. So solve the linear system, and here are the equations. So the first equation is x plus z plus 2w equals 6. And you notice I'm leaving a bit of space here, and you might think that's weird to do, but here's the reason. There's 4 variables in this system, and the x, y, z, and w. And the first equation just simply doesn't contain a y. So in order to make it easier to keep everything lined up, I'm going to leave that extra space so that when I can, this column will be dedicated for the y. So in the next equation, for example, it actually doesn't contain an x. So it's going to be y minus 2z, and it doesn't contain a z either, equals -3. And that you can see that I'm keeping my z's lined up here. I'll have this will be where all the y's are, this will be where all the x's are, and this will be where all the w's are. I'm leaving this room. It'll make this all the more straightforward to write down the augmented matrix. So the third equation, the x plus 2y minus z is equal to -2. And then the fourth equation, it's 2x plus y plus 3z minus 2w is equal to 0. So this is our linear system. And we've got 4 equations and 4 variables. We are going to start by writing down the augmented matrix of this linear system. So remember, that's just the coefficients and constant terms without the variable names. So the first equation, we've got a 1, an invisible 1 here in front of the x and the z. There's a 0 because there's no y here, so it's 1x plus 0y plus 1z plus 2w plus 6, right? So this is going to be 1, 0, 1, 2, and 6 for the first row. Now our second row, we've got 0, 1, -2, and 0. And then for the constant term, we've got -3. And then our third equation will be 1, 2, -1, 0, -2. And then what else do we have? We have 2, 1, 3, and -2. And then a 0 for our constant term. So here is the augmented matrix. So what are we going to do first? Let's do the same approach. Start with the top left entry. Is it a 1? In this case, the answer is yes. We've got a 1 in the top left. If this were not a 1, that would be our first goal. We would need to make this a 1 somehow. So you can do that by interchanging rows or multiplying by non-zero constants if necessary. But in our case, this is already a 1. So there's nothing to worry about. Our focus is immediately going to be on the entries below it. And I forgot to mention something. There's something fundamentally different about the way we approach this example. We haven't hit that difference yet, but we're going to approach this example in a different fashion than we did the previous example. So remember that our previous example, we first did a forward phase to get to row echelon form, and then we did a backwards phase to get all the way into reduced row echelon form. Well, sometimes you might just decide right off the bat that you want to get all the way to reduced row echelon form, and that's what we're going to do in this example. So if that's the case, it's possible to just do the forward and backwards phases together in a single pass. So as we go from left to right, we are going to make sure that the end result is in reduced row echelon form, and we're going to do it one column at a time. But our first challenge is this leading 1 here. It's going to need to be the only non-zero entry in its column, right? So we better make sure all of these are zeros. Of course, this one already is, But nonetheless, in general, these are the entries you're going to be looking at first. So these must be 0. Okay, so what are we going to do? Well, this doesn't matter. We've already got this exactly what it needs to be. So this, how about let's subtract row 1 from row 3 once, and then to get rid of this 2, we can subtract row 1 from row 4 twice. So we'll choose our row operations. So this will be row 3 will be replaced with row 3 minus row 1. Row 4 will be replaced with row 4 minus 2 row 1. So what will that get us? First 2 rows won't change, so let's start with that. 1, 0, 1, 2, 6, 0, 1, negative 2, 0, and negative 3. So those 2 rows will be exactly the same. Now the third row, what are we doing? Subtracting the first row. So 1 minus 1 will be 0. 2 minus 0 is going to be 2. Negative 1 minus 1 will be negative 2. 0 minus 2, again, will be negative 2. And then we've got negative 2 minus 6, which will be negative 8. So that's our third row. The fourth row, we're going to take this row and subtract row 1 twice. So 2 minus 2 times 1 will be 0. 1 minus 2 times 0 will be 1 still, you're just subtracting 0. 3 minus 2 times 1, that's going to give us a 1. We've got negative 2 minus 2 times 2, that's going to be negative 2 minus 4, which is negative 6. And then now we've got 0 minus 2 times 6, which is negative 12. That's going to be 0 minus 12. So that's what these operations will bring us to. Now, we've got these all turned into zeros, which is what we expected, right? That's why these operations were chosen. So it's no surprise that these are all zeros. But the way you should think about this is the first column is now perfect. We're just going to move one column over now and work our way to the right. So next, well, we would need to get a leading 1 here if possible. And great, it's already here. We already have a 1 here. This example has been very friendly in that respect. So once we see a leading 1 here, we need to look below that leading 1, and we know that these are going to have to be zeros. But here's where this example is going to be a little bit different in our approach. If this upper entry were anything other than a 0, the forward phase of the Gauss-Jordan elimination method would just ignore it for now. But there's nothing stopping us from also looking up here and saying, is this 0? Is this entry a 0? And if not, let's make it a 0. This is going to matter more on our next step. But for now, because this is already a 0, so there's no action that we need to take. But because we're doing both phases simultaneously here, we're going to also look above the leading 1s and make sure that they're zeros. So even though this entry is already a 0, I want to circle it along with these entries because I want to really make the point of telling you where your focus would be next. So these must be 0. So even though one of them already is 0, those are the entries that you're looking at. So we don't have to do any action here. This is already a 0. But for this 2, we can take care of it with this leading 1. So let's subtract row 2 from row 3 twice. And then we can subtract row 2 from row 4 once. And that'll have the effect of getting rid of this 1. So our first 2 rows won't change again. So we'll have 1, 0, 1, 2, 6 for the first row. Our second row will be 0, 1, negative 2, 0, negative 3 still. Okay, so now the changes are going to occur. So if we subtract row 2 from row 3 twice, well, 0 minus 2 times 0, that'll still be a 0. 2 minus 2 times 1 will be a 0. Negative 2 minus 2 times negative 2, that's like negative 2 plus 4, which is going to be positive 2. Negative 2 plus or minus 2 times 0, that's just negative 2 minus 0, so that'll stay a negative 2. And then here we have negative 8 minus 2 times negative 3, so that's negative 8 plus 6, which is going to be negative 2. So that's our new third row. And now our fourth row, we're taking row 2 and subtracting it from row 4. That's what this operation says. So our fourth row is going to become, well, 0 minus 0 will still be just staying a 0. 1 minus 1 will be a 0. 1 minus negative 2, that's going to be 1 plus 2, which is positive 3. Negative 6 minus 0, that'll still just stay as a negative 6. And then finally we have negative 12 minus negative 3, which is the same as negative 12 plus 3. So that brings us to this form. So notice how we've just worked our way to the right, taking care of each column one at a time. So we're always looking for this nice downward staircase of leading ones. So that would put this as our next culprit for an entry that we would like to be a 1. So how can we make this entry a 1? That's the next question. But that's our goal. This must be a 1. Well, remember, if you have a non-zero entry and you would like it to be a 1, you can multiply that entire row by the reciprocal of this entry. So we are going to take row 3 and replace it with 1/2 row 3. So multiply the entire row by 1/2, and that'll do the job.